Welcome to the video lecture on photoelectric effect offered by Dr. L. Chandrilla, Professor and Head, Department of Chemistry, NIT Trichy. Photoelectric effect is the emission of electron from metal when light shines on it. As energy required to dislodge a conduction electron, or otherwise known as electron in the outermost orbital of the metal, is lower than that of the inner electrons. Photoemission of electron occurs from conduction electrons. Hence, it is an interaction between the incident photon and the outermost electron of a metal. A single photon can dislodge a single electron if its energy is sufficient enough to overcome the binding energy of the electron. The binding energy is known as work function of the metal, and it is related to the ionization energy of the metal. Lower is the ionization energy, better is the photoelectric property of the metal. When one photon of energy more than the required energy is incident, it ejects one electron along with kinetic energy. On the other hand, photon of energy less than the required energy, if is incident, does not show photoelectric effect. Hence, the minimum frequency that is required to cause photoelectric effect is defined as threshold frequency and denoted as nu naught. If nu, the frequency of the incident light rays, is greater than nu naught, then the electron is ejected along with energy equal to the kinetic energy. In case, if the frequency of the incident beam is less than the threshold frequency of the metal, then no photoelectric effect occurs. When the intensity of the light is increased, then the number of electrons photoemitted also increases. So it can be summarized as increase in intensity of the light of frequency nu naught and above increases the number of photoemitted electrons. If we increase the intensity of the light, if it happens to be lesser than the threshold frequency, then we can't expect any photoelectric effect at all. When a plot of the kinetic energy of the electron is made as a function of the frequency of the photon incident, then we get lot of information, and that we'll see now. By writing the equation for the energy conservation, the energy of the incident photon h nu is equated to the sum of threshold energy and the kinetic energy. Kinetic energy is represented as half mv squared. Rewriting this equation in terms of kinetic energy, we have kinetic energy to be equated to the difference in the incident energy and the threshold energy. If we look at the plot, then we observe, number one, when the frequency of the incident beam is increased till reaching a value known as the threshold frequency, no photoelectric effect occurs. At the threshold frequency, photon is able to emit the electron from the metal, which we call as the threshold frequency. beyond the threshold frequency, when the frequency is increased, the emitted electron possesses an increasing value of kinetic energy, which can be read by referring to the y-axis. The slope of this curve, which is basically kinetic energy versus nu curve, the slope of this curve gives the value of the Planck's constant and the intercept giving us the value of the work function of the metal. When the plot is extended to the y-axis, we get the value of the work potential or work function of the metal.